So good morning, everyone. Welcome to our Lighting Talk series on the smart cities. And we want to use these opportunities and to share some latest advance and progress in both research and industry. So for today, we are very happy to have Macias Offrey to give us a talk on the power of digital twins. Macias Offrey is a technical account manager at the Siradel, North America. Siradel is specialized in building 3D digital twins and collaborative smart city explorer platforms. Those platforms can be designed to help city officials in driving smart sustainability and resilient projects to transform our urban centers. So without further ado, I will pass the screen and the mic to Macias. Go ahead.
Thank you so much. Thank you so much for the University of Texas hosting to have us today for this occasion to present a bit more our vision on digital twins. So very quick intro. As we were saying, I have worked for Siradel. We build a 3D digital twins for cities. For those who don't know what are digital twins, they are duplicates of cities in 3D on which you can aggregate any kind of data, whatever the source, whatever the formats, and run simulations in order to assess the efficiency and the impacts of future public projects.
Are you sharing them in the full screen, or like the view we see is in your slides view?
Yeah, if you're okay, I'm gonna leave it like this because when I'm having a full screen, it goes a bit everywhere, and so I prefer to have it like this because I'm gonna jump in and out, and so I prefer it like this.
Yeah, that's perfect. I'm just seeing if you don't aware that.
Yeah, well, okay. Yeah, fix it away. So first, I would like to talk about facts about challenges that the cities are having. So when a city is wants to implement a smart city strategy, well, it will involve many different organizations because cities are part of a whole ecosystem. So starting internally with their own departments, so urban planning, zoning, public works, GIS, police, you name it, even elected people. So you have already a lot of different groups of people within the city. And there's also higher level governments like county level, regional level, national level entities. And also it's important to precise that all these departments are made of technical and non-technical persons, meaning that not everybody can understand the work of the other departments, which brings even more barriers to common work and discussions. Also, in the case of big cities, you often have the energy or the public transportation, which will be separated in entities from the city itself. Like in the case of Austin, you have Austin Energy for the energy, sorry, and Capital Metro for the transportation. Also, you have for technology suppliers or private companies, which will play a major role because they will, for example, for telecom operators, they will provide the telecom infrastructure, so like 5G, fiber, public Wi-Fi, which are the backbone of smart cities. You also have IoT providers, which will provide sensors, and generally, these sensor providers will provide these sensors for one vertical at a time, like for example, air quality sensors, flooding sensors, traffic sensors. Also, you have the residents, which want to be consulted and involved in the city project. So, and they want to know how the city, for example, intends to use a new tax, for a new project, which is the case for Project Connect. So it's important for the city to communicate with them in a clear and a very transparent way.
We usually meet at 11, right?
I know. Well, it's like the robotics one that I joined for you guys. For me, it's like they do.
Okay. So all these groups of people are using different tools, very different types of data, and they all have very different levels of knowledge. So if you don't have a centralized base to make them all exchange and talk together, it's really hard to have a common vision. On the vertical aspect, so here I've listed only a few verticals, but they can be like of course, way more. It's going to be, it could have listed EV stations, water, air quality, noise. It can be hundreds. So on the vertical aspects, when implementing new project, it's really easy to think only in one vertical. While in a density, each of these infrastructures will impact each other. And more importantly, cities can make very important synergies and savings in terms of project cost if they decide to take into account the other infrastructures. So a good example would be, for example, if the city wants to install EV charging stations, well, you'll need to bring power to these stations. So it would bring a lot of synergies, for example, to consider bringing also other infrastructures at the same location, like CCTV, like smart lighting, like public Wi-Fi, in order to use the same power source. But for this, you really need a clear and holistic vision of your city with the ability to exchange a lot of information easily. So this is why the digital twin will have a central role in the development of smart city projects. I mean, I need to precise that this is Siradel's, I mean, our definition of digital twins. Not everybody has the same approach. So yeah, so on the organizational level, the digital twin will become a common base, a common repository for all the data from all these different organizations and groups of people. And on the vertical level, once the digital twin is complete, the idea is to run simulations which will allow which will allow to assess the efficiency of a public project and also its impact on other verticals. So I will precise a bit more my thoughts and our approach with this next slide. So what is Siradel approach for a smart city for smart city projects? So we start with co-constructing the 3D digital twin of the ecosystem of the city. So we have to know that Siradel has been an expert in geodata since 27 years now. So we either produce our own 3D data for the city, or we have it already off the shelf because we have been doing this for years. And if the data is not up to date, for example, they will, like 1 or 2 years old, there were like new buildings incoming, we are able to manually build these new buildings in 3D. So once you have the 3D base, the idea is to bring data, to aggregate data from all the different organizations in the ecosystem. So we have the capability in-house to process and clean and structure any kind of data, whatever its source, whatever its format, so that it all makes sense together and everybody at the same level of information. The idea is really to break data silos. Data silos would be, sorry, like one department having one kind of data and which won't be georeferenced or wouldn't be like very structured. It would be like really hard to like cross it with another dataset from another department. So we are able to clean everything in structure and make this and cross all these datasets together on one platform. So a typical example would be for data crossing. It would be if you have the utility company of the city, which builds a DHC, a district heating and cooling network in the downtown. You start with importing the future impacted roads because of the public works. And then you import, for example, the bus lines from downtown. And this way, when you have when you have to adapt the bus lines according of when the roads will be blocked because of the public works. On the simulation side, so after this, we are able to do, so thanks to our 3D capabilities, we can do simulations. The idea is to assess the efficiency of a future project in the city, but also assess its impact on other aspects of the city, like technical, social, environmental aspects, either positive or negative. Like, for example, if the city wants to develop a new bus line, with reserved lanes. So first we're able to assess what will be its efficiency with KPIs like speed for users, point A to point B, but also its impact on pollution levels due to cars. Because, for example, if you already have a section of the road which has high traffic, and you reserve a lane only for the buses, well, it won't be very efficient because you will just have a higher traffic, and it will slow the traffic for car users, and it will bring more pollution. So that's a good example of crossing different simulations together. Or for a second example, if you want to simulate the solar potential of all the rooftops of a city, while we are able to compare the cost savings between these solar panels and regular classic gas network. So this is because from these simulations, we are able to generate indicators which will be defined in advance with the members of the project in order for even non-technical persons or technical and non-technical persons to really understand the results of a complex simulation. For example, a non-technical person like an elected person won't be likely to understand the simulation of air quality or GHG infrastructure. So the idea is to give everyone the same level of understanding of a project with a global vision of its impact in order to take very efficient decisions. The last step as well is to be able to share and promote, because we have a very strong expertise in web design. We are able to customize and promote the result of a study. So I have an example in the slide just after. This is in Ile-de-France. This is a platform we have been working for, the Ile-de-France region. The Ile-de-France region is the Paris economic region. And this is a public site that everybody can access. And we have mapped in 3D the whole region. And this is in order to promote the adoption of solar panels. So for example, in that case, you click on one, so it's color coded depending on the potential in terms of solar power. And if you click on you can type your address and you can click on your own building, and you will know your solar potential on the roof. And then take action if you want to. This is a few examples of few use cases of simulations we can do. So 4G, 5G, Wi-Fi optimization, small cells, but we can also do mobility, bus, rail trail simulation. Also optimization of smart lighting, solar potential, green roof. So this is only like the use cases which are the most used, but you can do plenty of others. Before jumping to some use cases, I would like to show you this slide, which sums up a bit where we stand in the ecosystem. So we can feed, you can feed the digital twins, obviously with 3D geodata, but you're able to be connected with sensors, with connected infrastructures, meaning like if you have sensors for 5 different particles, we're able to connect all of them together and make them talk together, because often sensor providers have their own platform for their own sensor, for their own particle, and they don't necessarily talk with other sensors. We are able to obviously, as I said before, to import data from the whole ecosystem. We can connect to open data portals already in place and we are very flexible. We are able to bring analysis and results from other engines, from other softwares. And as an output, we're able to we will have your CD in 3D, so we're able to really visualize and understand what's the current situation. We're able, as I said before, to cross-correlate and to control infrastructure thanks to sensors, simulate scenarios, and as I said before, calculate the impact of a new project through the creation of KPIs. So now we'll jump to the Austin digital twin. We already have built a digital twin for the city of Austin. So it's right here. So this is Austin in 3D. As I said before, for those who will know the city of Austin, there might be a few buildings that don't appear yet because this geodata is like 1 or 2 years old. But as I said before, we are able to manually build them, like manually to make it up to date. The university is here, and so this is the first step. This is a 3D digital model. After this, we're able to. The next step is to bring datasets from different sources. So I just clicked on viewpoints. We have different viewpoints, and you can have like different views of different datasets in the city. So this example, in that case, what is imported are the Austin corridors. These icons are showing traffic fatalities, and these ones are showing traffic detectors, traffic cameras, and they are color-coded depending on traffic detectors. They are color-coded depending on their status. So, for example, this one in red is broken. This one has been removed. This one needs verification. So this is a good way to cross-collate different datasets. So we know that, for example, here there has been like a traffic fatality in 2019. And around it, there's some traffic detectors which are not really working. So it's a good way to be aware of some, to prioritize some areas of the city which need improvements thanks to this. Another example would be, for example, Austin corridors and future streetworks. So in that case, in orange, you have the future corridors. In blue, you have bus lines. And in red, it's future streetworks. So you know that these areas, this part of the bus lines will be the bus won't be able to pass because of this of the future streetworks. So you can anticipate this and make it turn around. So this is some example of data crossing. But then I think you can go even further. So as I was saying before the beginning of the call, we are, for those who watch last week session, Jeffrey Deku was representing about the pin poles, which are with the project which might happen in Austin. So Jeffrey gave us the location of this poles. And when we, thanks to our engines, we were able to do an optimization of the location of these pin poles. In that case, it's for 5G small cells. So we were able to have an optimization of the location of this 5G small cells thanks to our 3D tool. And this is the first step. So this would be like the base. And for example, we are planning to do 1 or 2 more simulations to show how digital twin can be powerful. In that case, we know that Project Connect, transportation project of Austin, aims to bring a new line, a BRT, bus rapid transit line from south to north in the downtown of Austin. And for this bus rapid transit to operate, it needs to have sensors, traffic lights, so giving priority at traffic lights. And for that, it needs to be near small cells to have bandwidth around it. So what we can do, for example, we know that this is the best locations for the pin locations. And so on top of that, we can decide, okay, where should we put the traffic sensors? So it's an example. Another example would be to simulate what would be the best pins to add CTVs. So thanks to this, we're able to aggregate a lot of different simulations and really bring synergies when having a lot of different projects in the city. So that's it for the digital twin and for my presentation. If you have any question, please do ask away. I hope it was clear. If you have any question, please.
Thanks for the talk. It's very interesting to see UT in a different perspective. I want to open for the questions. If anyone has questions, please feel free to unmute yourself and ask. But I'm curiously on how you normally generating the 3D model for the city. I think you mentioned something, you had some old data, then you do some manual modeling for that. Is that how the general process goes?
It depends on how old will be the data. So as I said, we can produce it by ourselves. We have partnerships with a lot of companies which are doing, for example, with satellites or with plane are doing LiDAR acquisition. But if we already have the data, which is like 1 or 2 years old, in the case of Austin, for example, it's almost up to date and we can manually recreate the new buildings so it can be up to date.
So you don't have an in-house tool to say, go from satellite image to automatically generating 3D models?
Sorry, say again?
So do you use or do you know there's any tools that can help to generating 3D model from, say, a satellite image of the region?
That's what we do. This is from the satellite image that we generate. We model our own 3D model from the satellite image. We have the raw LiDAR data, and then we build in 3D whatever can be in kind of, this is like what I just showed you was like the lowest quality level, but you can go like way more in detail.
Yeah, so this is something you developed in-house in your company to work on. Okay.
Yes.
I see.
I have a question on the data side. Right now, did you get the data from Austin government or from other sources? I know Jeff provided the pin locations, but for other data you showed on the map, where did you get the other data?
So very good question. Each time I'm building a digital twin of a city like this, I like to import data from very different sources. So there was a pin location, as you said. I also went on the Austin Open Data Portal. I went also on the Texas Open Data Portal. And then I also went on, so this is a use case, another use case, which shows attractivity for new companies to come in Austin. And I've added the data for investors, key locations, and startups in Austin. And this is coming from another website. I don't remember the name, to be honest, but it was a startup website of Austin, which was also providing this location. So it can be from anything. But this is digital twin made from only available public sources. We are not working yet. We are working a little bit, but not in depth with the city of Austin. So I've just built digital use cases only using the data which can be available. But if we work closely with the city, of course, we can aggregate way more.
So this website or this platform, something you design yourself. It's not based on Google Earth or other platform, right?
No, this is our own platform, yeah. SC Web, Smart City Explorer.
Okay, another follow-up question is what you showed here is the display of information. A very important part of digital twins, we can do simulation, we can do analysis. You mentioned that you can do pin location analysis. What other analysis you can do with your platform?
Really good question as well. So I'm going to come back really quickly to one of the slides I showed before. So this is originally we are our core first activity is to work with telecom operators. So we are able using 3D to do 4G, 5G location optimization. So telling an operator where is the best location in the city to for like a given bandwidth with like 80% of coverage. We're able to know, okay, this is where you should put all these small cells, but you're able to do also solar potential, green roof potential. So this is using 3D as well and imagery, able to know like what are the best buildings for having solar potential and green roof, and then compare costs. What savings will you have compared to not having a roof or like relying of your classic gas system. Noise, street lighting as well. This is a project we have done in Washington DC. We are able to target to simulate the coverage of for a new Olympic project throughout the city. And for example, we're able to know, like, if you have a light which is here, but you have a tree bit here and pedestrian passage, we were able to see, okay, this area of the road will be dangerous for pedestrian passage. So we can do a lot of very different simulations, and also we are able to work with a lot of partners. When we can't do simulation, we have a lot of different partners which we work close to, and we'll be able to display their result of the simulation.
You have 9 different examples. I'm quite sure you probably have many more. So
yeah.
let me ask. So what is the mostly highly demanded simulation for different cities? It's
There is a what?
Like when you talk with different cities, like say maybe 5 or 10 want you to do simulation on traffic, or maybe 1 just want to do a simulation on street lighting. What's the percentage? What's the most high demand simulation they want you to do?
That's a very quick. So honestly, I don't know which one is the most asked, but as you said, you were right. We have way more simulation than these ones. So these ones will be the most asked, to be honest. This is the most popular ones. Maybe if I can give you like a top 3, mobility for sure, because we are able to simulate bus rapid transit, classic bus, light rail, autonomous vehicles, and the other one would be maybe solar potential.
When you simulated the traffic or transportation part, do you use the existing transportation modeling software like Transcad or vSim, or you use your own software to do the simulation?
We have our own software.
So
we have an expertise.
So your own software can generate the demand at a different neighborhood region, or what kind of result we can get from that software? So
we do not generate the data. We have partners such as Streetlight Data, which give us the mobility data, the traffic flows. But we have our own in-house mobility simulation software. And as an output, the KPIs we'll be able to release will be traffic. So will be also accessibility. Actually, I can show you. It's going to be way more simple. Like we are able to generate 10 different KPIs. It's going to be always way better when you show actually how it is. So this is, for example, accessibility. Oops, sorry, it's not. So this would be, for example, after the development of a new line within the city of Vancouver, we are able to show the accessibility. So for example, like you have a line which goes from here and goes up to here. All the buildings in color will be the most affected ones in terms of like gain of transit from where do they live until the other point. So this is one of the examples, for example.
Okay, thank you. That's very useful. Thank you.
I think we have one more questions. Aya, do you want to ask?
Yeah, so I try to make it very quick. So you mentioned that the source of the data is not yourself. So you are getting the data and you were showing, for example, the startup in the city of Austin. So I was wondering, do you have like an evaluation about the quality of your data and how complete your data are?
Yes,
What are the limitations behind the data that you're using?
that's a very good question, because it's something I said quickly earlier. This is one of our strengths. We have what we call smart city managers in-house. So it's experts which are able to first gather all the stakeholders of a project, and we talk with each departments and figure out what do they own in terms of data. And then they will bring back all this data, and they will spend sometimes a lot of time in cleaning the data, meaning if it's not georeferenced, they will georeference it by themselves. There's a lot of way to do it. They will, like, for example, delete duplicates, and they will structure it in a way that all the data sets are structured the same way. And then only we are able to bring everything together. So yeah, we have a whole process of this. And what would be the limitations? Well, it all depends on what the city will give us. But generally, we have been doing this for years, so we maybe maybe for example we have like one address in terms of like instead of geolocation, like actual coordinates will be harder, but there's still a way to make the data talk. Did I answer your question?
I think you're still muted.
Yes, thank you.
Yeah. Okay. Great. So we're a little bit over time, so I want to just close the session here. But if you have further question, we will be happy to relay the question to Matthias after the talk, and also our talk will be has been recorded, and we will posting them on our site, on our website, smartcity.tech.uts.edu. So I just want to thank Matthias for a very interesting project.
Thank you so much.
Thank you for your time, and have a good weekend. Bye,
Thank you.
everyone.
Bye.
Thank you. Thank you for.